Okay, so here we are going to look at two examples of calculating branch target address. So here we have a label that is called here. So that's our label. And this label has an address of basically this one. So 400018. So that's the address for this label. It has S1, S2, and the I. So we want to calculate the BTA from given I. So that means originally this BNE S1, S2 had a label here, like so it has like loop, for example. And here this is already assembled. So this loop has gone through that formula, and it's actually now it's in the form of I. So it's like that number. So it's a form of an offset. So we can basically decode these and like look at and find the original BTA or original target address, so the original location of this loop. We cannot find what is the label actually called because that information is completely lost when you assemble, but we can find where was this located. So here we have our instruction given to us. So it's already assembled. And now let's look at how we can get that. So first of all, this opcode and RS and RT, so these are representing to this S1 and S2. We already talked about that. We're not gonna look at this in this slide. So we have our I value, that is this. And we had our formula. That was BTA is equal to PC plus 4 plus offset. So in this question is asking for BTA. So this is what I want. So BTA is equal to PC. So what is PC? PC is the current line that the branch is located on. So here we have this label and we have this address. So that's the current line. And I'm gonna actually put this in, so 4 and 4 in 32 bits. So what is PC? PC is gonna be this line, the current line. So that's 0040 0018, and that's in hex. Okay, let me write this properly. So that BTA is equal to hex 0040 0018 plus 4 plus offset. So what is the offset? We don't have the offset here right now. So we said that if we have offset and I, we said there is a relationship between them. If you want to go from offset to I, so remember, I is the compact one. So you are dividing by 4 or shifting to the right. So shift to right. If you are going from I to offset, so you are kind of expanding and you are shifting left by 2. So here we have the I. In order to get the offset from the I, we have to shift to the left by 2. So that means basically you're adding 2 zeros at the beginning of that. So if this is your number, you add the 2 0. I'm sorry, this is your I. You're adding the 2 0, and you just then have to sign extend that. So I want to maybe write this just to be more clear. It's a bit tricky when you add these two. You want to divide them by 4 digits to be more clear, not to confuse. So if I have these two, so you see that this one, the last 4 digits is 0100. So that's what we have here. And then you see that the rest of it is actually 0. If it wasn't, you had to only still sign extend. So even if at the end you had a 0, you would still sign extend this one. So now that you have that, you basically sign extend everything, and you're gonna get all these ones. So that's now your 32 bits. So now you convert this one to hex, and you're gonna get basically for each 4 ones, you're gonna get an F, and this last one gonna be 4. This is 2 to the power of 2, 0, 1, 2. So this is 2 to the power of 2. So this is going to be your basically offset value. So I can add that now on my formula. So 0x f f f f f f f 4. So that is basically what I have in my formula. And then the next step is to add these. So I'm going to get 0x 4 plus this is going to be basically 12 or C. So 0, 0, 4, 0, 0, 0, 1 C plus that number. F, F. So 4 Fs, F, 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 and 4. So, and here we have the calculation actually. So this is the same number we have here, and this is that number. So you just add this, and you're gonna get this value. So this is your BTA. So that means, just to put it in context, that means if this branch was true, so this is not equal. So if these were actually not equal, we would jump, and we would end up on this location. So that is just to put it in the context. And that's how you convert from I, so you're given I, to BTA.